I'm Nick Flights, agronomist for Pentair Hypro. Today we're going to be talking about spray coverage. And spray coverage is a key component of any spraying operation. But coverage is kind of an idea that's hard to visualize in your mind, especially if you're running a sprayer, you're in a cab, doing 15 miles an hour across a field. How do you know if you're getting good coverage? How do you know if you're getting bad coverage? So today we're going to be talking about two key things. First is going to be talking about coverage as it relates to the specific type of chemistry we're applying. And then we're going to be sharing with you kind of a neat new way we've found to visualize coverage in your own spraying operation. So we're going to be starting with tying the type of coverage or level of coverage we're looking for based on the type of chemistry we're applying. And so there's two main types of chemistry we use in ag spraying. We have contact chemistry, we have systemic chemistry. Now, a contact chemistry does not translocate within the plant. It only works where those individual spray droplets land. Now, a good example, most fungicides are contact chemistries, a lot of insecticides, and some really commonly used herbicides are going to be contact chemistry. Things like glufosinate, paraquat, PPO inhibitors are all good examples of contact chemistry. Because those chemistries do not move within a plant, we need to make sure we're getting uniform coverage across the entire leaf surface to get good pest control. So we're going to be using nozzles that are more focused on higher coverage applications. We'll use some other spraying practices to promote higher coverage as well. So on the other hand, we've got our systemic chemistry. Now these types of chemistry are going to move within a plant. We call it translocation. So a spray drop lands on a leaf surface, it will be taken up by the plant. It'll move to other shoots and stems, other leaves, down to the roots, throughout the internal structure of the plant. Because they're able to move or translocate within the plant, we don't have to worry about coverage quite as much as we do with our contact chemistry, where we really have to coat the plant surfaces uniformly. So our systemic applications introduce a little bit more margin for error, you could say. We don't have to have that high degree of coverage, so we can use nozzles or other spraying practices that will help us reduce drift, and we can kind of balance out that drift reduction in coverage and ultimately be a better steward in our application. Coverage in the field while we're spraying can be difficult to visualize and to quantify. So we're going to share with you a neat new way we've found to test for coverage and to make it visually easy to see with your own eyes. So we'll be using a UV dye. We'll be spraying that onto some plants, and we'll use a black light to illuminate those individual spray droplets. So we can tell how coarse a droplet we're using. We can see what degree of coverage we've achieved and how uniform it is from the top to the bottom of the plant. You can utilize this in your own spraying operation by getting an over-the-counter UV dye, spraying as you normally would into a crop, wait for it to get dark, get a handheld black light, and then go out in your field and look and see where those spray droplets landed. This will help you see the parts of the crop canopy that you are targeting well. It'll also help you see areas that your spray coverage is deficient and help you alter your sprayer settings, nozzles, application volume, pressure, things like that, and that will allow you to do a better job of spraying. So this is our spray chamber that we can simulate in an infield application using a 2-nozzle spray boom that can travel up to 6 miles per hour. We're going to use this to make our application of our ultraviolet dye, and then we will use a black light to examine the coverage our different nozzle and application setups provided. So here we are looking at our plants that we sprayed under our black light. The plant on the left was sprayed using the Pentair Hypro 3D nozzle. This is a nozzle designed with a focus on achieving higher coverage, utilizing a coarse and medium-sized spray droplet. And it's a nozzle we commonly recommend for the application of a contact chemistry, applications like fungicides, insecticides, and contact herbicides. And if we look at the leaf surface, we can see two things that really stand out. First is how many droplets we created. There are thousands of droplets covering the leaf surface and covering them uniformly. And we see very little space between the individual spray droplets. And we'll compare that with the plant on the right that was sprayed with the Pentair Hypro Ultra Low Drift Max, and that's a nozzle that's really designed with a focus on drift control. It's going to produce ultra coarse and extra coarse droplets, and we can visually see that droplet size difference by looking at the leaf surface. We can see how few droplets were created compared to the previous plant, and we can see that there are large areas of the leaf surface between the individual spray droplets that weren't covered. The leaf surface area left uncovered between the individual spray droplets would not provide an effective control of a pest if we're applying a contact chemistry. So if we're applying a contact chemistry, we really want our application and the coverage to look similar to what we're seeing with the plan on the left. If we're applying a systemic chemistry, most likely a herbicide, this level of coverage and droplet size will still provide effective weed control because that plant is going to uptake that herbicide molecule and it's going to translocate within the plant. And that allows us to focus more on drift control in those applications than we're able to with the contact chemistry that requires the finer droplet spectrum to be used to maximize leaf surface coverage.